Hi, we're back again. Now, this is onto part 3. Just unclip the scope. I was just checking something. I'll show you that in a minute. So, we basically got all the capacitors fitted. We've got the resistors done. Now, I decided not to in the main use the resistors in the kit. They've been in and out a number of times. A lot of bends on them and so on and so forth. The leads are probably a wee bit weakened. So I decided, no, I'm not going to use them. The only one I used out of the kit, in fact, was the 333K. And 330K, sorry, 333,000 ohms as they say, but 330K out of the kit. I've got plenty of 330Ks, but there's my drawers there, and the radiogram's in the way. I can't get them out, so I decided just to go this way. Anyway, so we found that there was a problem with the coil in the ferrite for the medium wave coil. This wire was burst, so that's been repaired and soldered. The other thing we found was the little tiny fine springs for that go on to the ends of the controls and so on. So there's a spring goes in there and you put your wire through. They weren't there, so I just soldered them. That's fine. These wires can stay on because in the main most of the wires are long enough to go to different projects, so that'll be fine. Transistors are not fitted as yet. There is a reason for that. The reason they're not fitted is simply because I want to check them, and I also want to make sure this hasn't got any tin whiskers before I bother even putting them in. Because if they're faulty, I just need to go into my germanium transistor drawer and find some. Now you'll be wondering why I decided to put the scope on it. I was just to check to see if I was getting anything off the ferrite rod. I'll turn it round slightly. I'll poke that in there. Don't know where my clip is. It's disappeared, just like everything else in here. Things disappear all the time. I don't know why. So I shall turn the tuning knob while I look at the scope. Right. As you can see, they're coming up with a signal. It's a bit too bright. There's one station there and another station there. That's about all you'll get now on medium wave. Well, there's one further down, right as it's at 200 end. So there you go. That's actually just a signal coming off the ferrite rod. So of course the transistor amplifies it. So basically this is what you call a reflex circuit. So the first transistor does two different things. Obviously it amplifies the RF, and it also amplifies the AF. I haven't fitted the radio frequency choke in there, so that's another thing I've forgotten to do. So this winding on this coil has two. One, the longer winding is for the tuning, right? That's what you pick up the magnetic wave from the transmitter into the ferrite rod, and it's tapped off, or not, it's transformed off if you like, with it's maybe a 2-turn or 3-turn winding on here. So it goes between the base of the transistor and believe it or not, the output of the diode. And you'll be thinking, well, why is that? Well, it's actually quite simple. So this 47,000 picofarad capacitor here is the path for the RF coming off it back down to ground. Okay, so the RF is going into the transistor, and the transistor amplifies that RF. So you have a choke here, right, and what that does is that stops RF going that way. You'll only get AF going that way. But it also, when it amplifies, you'll notice it's going through this capacitor, right, and this capacitor actually detects, that's your detector of the RF, right, that's coming off here. The RF doesn't go that way, it goes this way, right, and it's then getting fed back into this coil. But for that, because it's audio, that doesn't matter. That coil, as far as it's concerned, is a length of wire. So it's then going back into the base of the transistor. It is then amplifying the audio as well as amplifying the RF. So the audio comes back out the collector, just as it does with the RF, but the RF isn't going that way. It's only the audio that is going that way. So that's your audio that's amplified. And it goes through the coupling capacitor, through this wire here. This is a filter cap. That's filtering out any residual RF. So this is your output from your first transistor, and it goes into the volume control, comes back out the volume control, and then goes into the base of the first audio amplifier. So this transistor here, this EF116, is doing a double duty. It's acting as an RF amplifier and also as an AF amplifier. That's why we call it a reflex circuit. So it's amplified by this transistor here, and it's actually at a reasonable level by that time. We'd be able to drive a pair of headphones absolutely no problem at all. And then it goes into the final transistor, which is a class A amp for the speaker, which, as I already explained, is 80 ohms, high impedance high impedance loudspeaker. Now you'll be wondering, well, what's the rest of the stuff doing here? So this here, this 4700 ohm or 4.7k is the collector load. This capacitor here is a coupling, so there's no DC from this circuitry getting into the volume control or getting fed back into this amplifier. This is it's just a limiting resistor basically, and these are two smoothing capacitors, a bit over the top to be fair, in something like this. One is probably sufficient, and also it should be bypassed by a smaller value to take care of any RF that's getting, if you like, escaping. But in a circuit as simple as this, it's not necessary to overcomplicate things. Again, we have, I should go back here, this 680k and this 330k and this 47k are what is known as bias components. So that gives the transistors a little bit of bias. You probably haven't seen this way of doing it in transistors before if you've ever watched it, done anything with transistors, but there is an advantage in doing it this way. A lot of people say, oh, it's rubbish. It's not. In actual fact, what we have here is DC negative feedback. So what happens is if your transistor starts to conduct high, this collector voltage will tend to drop, right? So you could be heading for thermal runaway, right? So what would be happening is it conducts more. In theory, it keeps conducting more and more and more until it starts to get very, very hot. But what happens here is when that happens, because of the load that's here, right, that voltage gradually drops. So if that voltage drops, the voltage on the base drops. And because it's dropping, it actually biases the transistor further off. So that's what we call a bit of DC negative feedback. Very good way of biasing transistors, but not something that is universally used these days. It works fine, and it makes the transistor more stable as well, that particular stage. So it works in all three. So that's your collector load. That's the collector load for the amplifier, and the collector load for the output is the loudspeaker. This here is like I say, this is a filter capacitor. This is a coupling capacitor, just to doubly make sure that there's no DC path from the base down to ground, which we don't want. If you don't have that capacitor in it, you've got the value of the resistor, which would affect the biasing. So we have that AC coupled rather than DC coupled. So it's a very simple circuit. It would be better if it was a class B. There is in the Philips kit here, there is a push-pull amplifier which is class B, using two of the AC126s and the preamp using the EF116. Just because it's an RF transistor doesn't mean to say it can't do AF. Yes, it can. So there you go, that's the circuit. So I'm waiting on two 1289 batteries, but in the meantime, on my next video, I will run it up with a Pt3 and see how it works. And take mind, the ground is positive. It's a positive earth, it's a PNP transistor. The collectors run at negative, not positive. It's the other way around. And that's where a lot of people can make mistakes. And a lot of people also think, oh, is that the reason why cars went from positive earth to negative earth? No, it isn't. It's nothing to do with electronics whatsoever. A lot of people say it was down to galvanistic, or what you call it, galvanic corrosion and all that stuff. Believe that if you wish. I don't. They rusted anyway, no matter what way the battery was round. So yeah, some of the earlier cars, some of the 50s cars before the transistors came out, even before that, had valve car radios, and as we know, the what do you call it, the cathodes of the valve, which basically goes down to to ground were in fact negative. So the HT on the valve amp is, or radio, etc., has positive to the anodes, etc., and negative to ground. So nothing to do with that. If somebody tells you that, they're talking rubbish. So there you go, that's it. Next one will be the radio working. Hopefully, fingers crossed. Cheers.